In this video, we're going to learn how to verify trigonometric identities. So let's take an example. So you have sine x, sec x equal to tan x. Okay, so when you have a problem and you're told to verify trigonometric identities, okay, the first thing you want to do is you have to pick a side. Okay, so you can actually pick the left hand side or the right hand side. Okay, so if you pick a side, you now prove that it is equal to the other side. Okay, so before you start solving, I would like you to note the following relationship between sine, cosine, and tangents. Okay, so one of the things you need to notice is that sine square x plus cos square x equal to 1. Okay, and we also know that 1 plus tan square x equal to sec square x. Okay, and we also know that 1 plus cosec, cot is cot, not cosec, cot square x equal to cosec square x. Okay, so now we know that sec x equal to 1 over cos, and cosec x equal to 1 over sine x, and then tan x equal to sine x over cos x. Okay, so before you start solving or start trying to verify trigonometric identities, it is important that you know this relationship between the terms. Okay, so you can actually take the liberty of writing them down somewhere, because we are going to be using them while solving our problems. The first step when trying to, so before we pick a side, me personally, I like picking the left hand side of my equation and trying to verify the right hand side. Okay, so you can actually pick any side and try to make it look like the other side. Okay, this is sec x. Okay, so before the first step when trying to solve or trying to verify trigonometric identities is to convert your side to sine or cos. Okay, so because I'm picking this side, I'm going to try and convert all the trigonometric terms into sine and cos. Okay, so we know that sine x is still sine x, cos sec x is this multiplied by 1 over cos from our relationship. Okay, so we are placing sec x by 1 over cos x, so this is equal to tan x. Okay, so sine x times 1 is sine x over cos x, so this is equal to tan x. We know that sine x over cos x, so but tan x, from the relationship we wrote before, tan x is equal to sine x over cos x, so this is equal to tan x equal to tan x. Okay, let's take another example. Sine x, plus cos x divided by cos x. So the right hand side equals to tan x plus 1. Okay, so the first step is to pick a side. Okay, so I'm going to be picking this side, my left hand side. Okay, and I'm going to try to make it look like the right hand side. So from here now, we have to, second step is to make sure all terms are in causes and sines. Okay, so if we look at this part already satisfies that second step. Okay, so the next step is to simplify. So we have sine x. We can divide this numerator. This can also mean cos x, sine x over cos x plus cos x over cos x. Okay, so we know that tan x, but tan x equal to sine x over cos x. So this means that we'll be replacing sine x over cos x with tan x in this equation. Okay, so this is tan x equal to this part. Okay, plus now we know that cos x happens once divided by cos x, so it's 1. So plus 1 equals to tan x plus 1. Okay, so let's take the next example. Okay, so for this example, I'd advise that you pause the video and try this one out yourself. Okay, so like we did before, we have to pick a side first. So from the first step, let's pick the left hand side. Okay, we can also pick the right hand side, but for this one I'm going to pick in the left hand side. Okay, so for the left hand side, we have to convert everything to sine and cosines. Okay, so we know that tan x equal to sine x over cos x, and sec x equal to 1 over cos x. Okay, so we replace these terms with the tans. You use this sine and cos terms to replace the sec and the tans. Okay, so this becomes equal to, this is sine x over cos x square, okay, divided by sec x is 1 over cos x plus 1. Okay, so this is equal to 1 minus cos x over cos x. So if we square our sine and our coses, we have sine x, sine square x over cos square x, okay, divided by 1. We can simplify the denominator of this fraction, so it becomes 1 plus cos times 1 is cos x divided by cos x. Okay, so this is simply taking the LCM as cos x and simplifying these parts. So this is equal to 1 minus cos x divided by cos x. We can now say sine x, sine square x over cos square x divided by 1 plus cos x over cos x. Okay, so this is equal to 1 minus cos x over cos x. Okay, so to switch this division sign to multiplication sign, we have to multiplication sign, you have to switch the denominator and the numerator of this fraction. So this becomes sine square x over cos square x times cos x over 1 plus cos x equal to 1 minus cos x over cos x. So from here now, we know that cos x can go into itself once, and then cos x can go into cos x squared, cos x times. Okay, so this becomes sine square x divided by cos x over 1 plus cos x. Okay, so this is equal to 1 minus cos x over cos x. X squared can also be written as sine square x plus cos square x equal to 1. So if we want to replace sine square x with, we can replace sine square x with sine square x equal to 1 minus cos square x. So here we actually subtracted cos square x from both sides. Okay, so that it becomes sine square x equals to 1 minus cos square x. Okay, so that's what we are going to use to replace this sine square x here. So it becomes 1 minus cos square x divided by cos x, open bracket, 1 plus cos x. Okay, so now this is equal to 1 minus cos x over cos x. Okay, now from here we can actually simplify this further, the numerator further. Okay, so we know that when we have 1 minus, say, x squared, okay, so this is a difference of 2 squared, can be written in this form: 1 minus x, open bracket, close bracket, 1 plus x. Okay, so that's the same thing for this case. This thing can be written in 1 minus cos x, okay, and then 1 plus cos x. So we had a difference of 2 squared here, and it can be written in this form. Okay, so divided by cos x, open bracket, 1 plus cos x. So we have like terms on the numerator and the denominator, so they can cancel out each other. Okay, so this is equal to 1 minus cos x over cos x. So this left hand side is now equal to the right hand side. So we verified our trigonometric identity. Let's pick another example. Okay, so we are still going to have to pick a side as our first step. Now you can actually pause this video and try this one out yourself. Okay, so we are still going to pick a side. Preferably I'm going to pick the left hand side. Okay, so we have to convert everything here to sine and cosine. So we have 1 minus sine x times tan x is, open bracket, sine x over cos x. Okay, so this whole thing, this part, is divided by 1 plus 1 over cos x. From the definition of sec x is 1 over cos x. Okay, so I'm just going to be putting this sign here, which represents cos x. So this is equal to 1 minus, now sine x times sine x is sine x squared, sine square x, okay, divided by cos x. So here I'm going to be picking my LCM. Okay, so my LCM here is cos x times 1 plus 1. So this place is divided by 1 cos x plus 1 over 1 over cos x equals to this. Okay, this part. Okay, so this is 1 minus sine square x, okay, over cos x divided by cos x plus 1 over, so just to be noted, this part that's dividing each other, okay, cos x. Okay, so to convert this division sign to multiplication, we have to switch the numerator of this part and the denominator of this part. Okay, so this becomes 1 minus open bracket sine square x over cos x times cos x over cos x plus 1. Okay, so this would cancel out this. Okay, so you now have 1 minus sine square x over cos x plus 1. So we still need to simplify further because we have not gotten the cos x on the right hand side. Okay, so if we look at this properly, we can actually say sine square x, our trigonometric, fundamental trigonometric identities, sine square x plus cos square x equal to 1. So if you subtract cos square x from both sides, you can actually say sine square x equal to 1 minus cos square x. Okay, so this part becomes equal to 1 minus open bracket 1 minus cos square x divided by cos theta plus 1. Okay, so from here on out, we know that this can be seen as difference of 2 square. So this would mean that 1 minus cos square x can be written as 1 minus cos x, open bracket, close bracket, 1 plus cos x. Okay, so we are going to replace this one with these two brackets. So this would become 1 minus open bracket 1 minus cos x. Okay, so we have 1 plus cos x, and then there's a division sign of cos x. This is cos x, not cos theta, cos x plus 1. So this one can actually cancel out this one. So from here we have 1 minus open bracket 1 minus cos x. Okay, so this is equal to 1 minus 1 plus cos x. So 1 minus 1 plus cos x. So we have 1 minus 1, so they cancel out each other, plus cos x equal to cos x. So at last we have cos x equal to cos x. So we've proven that this trigonometric identity here is equal to this trigonometric identity here. If you liked the video, leave a like button, share with your friends, and subscribe. Thanks for watching.